I want to help make sure that everybody's gotten the right stuff from working through the handout for graphical transformations. So let's just make sure that everybody's looking at the same thing. I've got x squared entered for y1, and then I have entered hang on while I get a pen. I have entered my equations for y2 through y5 that way, and there were videos provided for you to show you how to do that. When you press graph, if you've got the correct viewing window, okay, remember that this first number is your x min, second number is your x max, this -5 is your y min, and the 15 is your y max to get the viewing window right. Let me make sure I am in the right mode. Yes. Okay, when you press graph, what you should see graphed first is going to be the equation that you have in y1, and then you'll see the equation for y2 graphed, and then y3, y4, and y5. They're going to graph one at a time. So, pressing graph, I obviously have something wrong in my window. So I've pressed on to stop the graph. Let's see what it is. I've left out the negative in my y minimum. There we go. There is y equal x squared, and then there's y equal x squared plus 3, which is, and there's x squared plus 1, x squared minus 2, and finally x squared minus 4. So the equation, the second equation, y equal x squared plus 3, that's, I'm not going to be able to draw on my curve, but that's the one that's the farthest up, the graph that's farthest up. So it looks like y equal x squared is this curve that comes down and goes through the origin. Y equal x squared plus 3 appears to cross the y-axis at 3. X squared plus 1, the third equation, crosses the y-axis at 1. Fourth equation crosses the y-axis at -2. Fifth equation crosses the y-axis at -4. So it appears, and it's not just the y-intercept that changes, but that's the point we can focus in on. It appears to me like the plus 3 and the plus 1 shift the graph up 3 and 1, and the -2 and -4 shift down 2 and 4 units. Now, one of the reason that I wanted you to enter the equations the way I wanted you to is so that we can go in and we can change the equation in y1 to a different equation and not have to mess with any of the equations in y2 through y5. So the functions that are being graphed there, if I change my y1 equation to absolute value of x, then what I've got in my second equation is the absolute value of x plus 3. The absolute value of x plus 1 is y3. The absolute value of x minus 2 is y4, and the absolute value of x minus 4 is the equation in y5. Now graphing, we see absolute value of x graphed first, and what we're looking for here is there's x, absolute value of x plus 3, there's plus 1. We're looking to see if we have the same effect even if we change our initial function. And I'm comfortable saying yes. Plus 3 shifts the graph up 3. plus 1 added to y1 added to the function shifts the graph up 1. So we can generalize this. If we have a graph of y equal f of x plus c, that's going to be a vertical shift, a graph shifted up c units. The entire graph slides up c units. If you've got y equal f of x minus c, so you're subtracting a constant from the function, then the graph shifts down c units. And it's really important for you to be able to look at an equation like those and predict how that's going to change on the graph. All right, in question 4, we're still adding 3, adding 1, subtracting 2, and subtracting 4. But we're adding or subtracting those constant values from x within the function. So our original function is y equal x squared. Then we're going to take a look at what does x plus 3 squared look like. What does x plus 1 squared look like? So I have already entered my equations using this format. And now I'm going to press graph and see what it appears that the 3, the 1, the negative 2, and the 4 do. So there's our original x squared function, and there's x plus 3 squared. Shifted over to the left. X plus 1 squared also shifted over to the left. So I'm thinking x minus 2 is going to be shifted to the right. And x minus 4 quantity squared is going to shift to the right 4 units. So plus 3 and plus 1 shift left 3 and 1 unit. And the minus 2 and the minus 4 shift to the right 2 units and 4 units. Alright, so if we change our first function to absolute value of x again, math, number, option 1, absolute value of x, close the parentheses. Now what we've got in equation y2 is the absolute value of x plus 3. And in equation y3 we've got the absolute value of x plus 1. y4 is the absolute value of x minus 2, and y5 is the absolute value of x minus 4. And the question is, do we still see a shift to the left 3 units and a shift to the left 1 unit for plus 3 and plus 1, and to the right for minus 2 and minus 4? There's our absolute value function. There's the absolute value of x plus 3. It is further to the left, and it looks like 3 units. There's absolute value of x plus 1. There's absolute value of x minus 2. And finally, the absolute value of x minus 4. So yes, we have the same observations. So to generalize that, when you've got y equal f of x plus c, that's going to shift your graph left c units. X minus c is going to shift your graph right c units. Now be careful. When we had the shifting up and down, plus meant up, minus went down. When we're shifting left and right, plus means left, minus means right. So you want to be careful about that.